Hello everybody, this is a bit of a fill video, hopefully should be quite short. I've been working on another project which is turning out to be somewhat more complicated than I had thought, but it's going fairly well, so hopefully I'll have a video on that at some point soonish, I don't know when. Anyway, this is a device I just bought off of eBay. Got it for a fairly good price, and it's quite interesting, so I thought I would talk about it here for you. As you probably guessed by the title, the PO on top of this stands for Post Office. 165A is the model number, and DAE/I is the code for the manufacturer of this device. It was manufactured exclusively for the post office and was only used by the post office. And some of you who are younger will probably be questioning, why would the post office be having custom electrical testers made? That doesn't make any sense. And indeed it doesn't, until you realise something. This is a bit of a history lesson, so bear with. Back in the very early days, before phones were invented, before the internet, before all of the modern communications, all long-distance communication was done by letter, where people would physically write on paper and then post it, and it would be carried by the post office and delivered. After that, there came a thing known as the telegram, which is where you would write on a bit of paper, take it to the post office. The post office would then send it electrically to the post office nearest the person you're sending it to, where it would then be written down again on a bit of paper and delivered by the postman. And this revolutionised communication because it allowed you to get messages around the country much faster than was previously possible, but it was horrendously expensive and slow, and there were lots of problems with it. But it was only natural that the post office was responsible for long-distance communication before, so this new method comes around, well, obviously the post office would handle that. So they did. The post office ran telegrams. And then these newfangled phone things came along, and these are not mobile phones, they were old, big brick things that you had to physically plug into the wall. Some houses still have them, but they're becoming increasingly uncommon these days. And they connected through wires. They connected through wires all across the country, and you could pick up the phone, dial a number, and speak to another person. And the logic at the time was, the post office does post, they do telegrams, the post office does all long-distance communication, therefore these newfangled phone things are probably the responsibility of the post office. So they were. The post office, or the general post office as they're called, were responsible for all phones in the United Kingdom, including GTN, which is the government phone networks, which are a kind of independent thing from the civilian phone networks. The post office was responsible for all of that. Until reasonably recently, I can't remember the exact date when British Telecom split off. I think they stopped going by the post office in the late 70s, early 80s, I think. So after the 80s, they were British Telecom. But I don't remember the date that they split. I'll put a thing on the screen to say. So anyway, the post office manufactured lots of custom equipment for their engineers to maintain the telegram network and then later the phone network. This is one of those devices. This is from probably the mid-70s-ish, I'd guess, by the branding and the sort of build of it. This is a continuity tester, and it works perfectly fine still, despite its age. I have some test leads here which I'll plug into it, and you can see has two 4mm plugs in the bottom. This is a fuse holder. All around are the things we plug them together, and it makes a beep noise. Another thing I'll point out, I don't know if it'll come across on camera very well, but this thing is ridiculously loud if you compare it to another multimeter, like say this here is my new multimeter. If I compare the continuity beeper on this, continuity, and short the probes out, this is much quieter. The automatic gain on the microphones might have evened them out, but this is way louder than the modern ones are. There is a logic behind that. The reason is because back when this device was in use, I would say almost all... Again, we'll go for a quick history lesson. The way phones work, the old phones had a physical copper wire where you had to physically make a circuit from the one phone to the other phone, had to be physically connected the whole way. And the way they would accomplish this is, in the very early days when there was only a few phones in each area, they would have a big board with plugs, like plugs, not too dissimilar to these kind of plugs there. I have one actually here. They use these plugs, which are... they're called post office jacks, actually. 3/4 inch, I think, is the other name for them elsewhere in the world. But in the UK, we call these post office jacks because the post office used them. Anyway, those... they would physically plug the wire from your house into the wire for the person you're trying to phone's house, and the circuit would complete through the wire, through the switchboard, and you could make your call. When they started having more people making calls and more phones needing to be done, the old system of operators, as they were called, where you would pick up the phone and you would hear someone say, operator, and you would then tell them, I would like to phone 12345, and they would go, okay, I'll put you through 12345, please hold, and then they plug you in and you could make your call. You still have to use operators for some things, actually. I think they still exist. Maybe, I'll check. But I think you can still dial 100 and get an operator in the UK. Maybe, I'll put it on the screen again if I can find out. But, yes, they were replaced with automatic telephone exchanges, which used... there was various different types of them at various eras, but fundamentally, they all worked based off of relays, and at this era, they were all using what are known as the Strowager relays, which was an amazing piece of engineering by Mr. Strowager, who designed them. And they're basically a big brick with an arm that would sweep up and down, and it would connect to the different things, so it would select the numbers from 0 to 9. They were horrendously loud. If you were in a big exchange, like you think the type of exchanges you'd get in a city like London or Birmingham or Manchester, there would be thousands of people making calls at any one time. The calls would be going all over the place. And when you have literally millions in some of these exchanges, like thousands and thousands and thousands of relays clicking and clacking around, those exchanges could be deafening when you're inside them. So the continuity buzzers they used had to be really, really loud to be heard over the background noise of the exchange operating. So that's why they're so loud. I'll open this up and show you the insides of it, because it works in a very interesting way. It's also rather evident it was made by a phone company once you take the back off. I'll just loosen the screws here if you bear with. I'll draw you a schematic of it in a second. It's very simple though. As you can see inside, we have a battery, a standard 9-volt battery. This actually had it's not an original one, but the one that was in this was date coded 1983, so I had to replace it obviously because it was no longer working. But we have a battery, this is the actual speaker, the terminals, and we have a fuse holder here to prevent it from failing dangerously, basically, if you do something stupid with it. This buzzer bit here is the interesting part though. This is actually the speaker from a phone handset. The phones people used to use would have like an earpiece and a microphone and a handle thing that you'd hold up to your ear, and there was a box that would sit on the table and you'd dial the number by turning the thing. So this is the speaker from one of those. And there is no electronics in this. This is completely mechanical. It's very interesting. The way it works is it has the diaphragm inside this that goes back and forth. The coil is wired in series with a switch contact. One side of that is on the diaphragm and one side is not. So as you put power through the circuit, the diaphragm will come down and make the circuit, and then it'll go up and, well, actually it would break the circuit, but the diaphragm will go in and out like that, making breaking the circuit. That causes an oscillation. I'll draw a diagram so you can see that now. So, I have the diagram here that I was talking about. I will point out the parts. We have over here a battery, 9-volt battery, that is this bit here. The switch here is made into this module, and so is this coil. We have the test resistor, which is the thing you've connected between the probes, and these two here are the jacks here and here. This module here is like the heart of this device. It contains everything that makes the sound. The way it works, as I said before, is very simple. This is kind of a cross-sectional area, so imagine if you cut this in half. This is approximately what you'd see inside. There's a metal cap here, which is the bit you can see on top. It has a couple holes in it, and underneath those are the diaphragm, which is this bit here, and there's another cup on the bottom. The diaphragm has a contact on it, and there's contact as well on the thing, and a coil going round the edges here. And the way it works is the switch is normally closed, so when you short the probes out like this, you short the probes, the current will flow through the closed switch, through the coil, through the fuse, through the thing you shorted it with, and back to the battery. That will produce a magnetic field on the coil, which will pull the diaphragm down slightly, and that will then open the circuit. So this switch goes open like that, the current stops. So the magnetic field in the coil will collapse, and the diaphragm will come back again and close the circuit, and then the current will flow and make the coil energize and pull it, and then it will break, and that cycle will repeat at the set frequency of whatever this is oscillating at. I'm not sure what frequency this oscillates at, actually. You can probably tell with the audio thing. I'll see if I can work it out, but it will happen however many times a second, and the vibrating diaphragm is what is producing the sound. So it's a very, very simple device, very, very clever, obviously very robust, because this has been used for probably 50 years and it still works perfectly fine. It's all around just a very clever piece of engineering. So let's measure the frequency this operates at, actually. Before we finish, I've left this bit of the screen clear so I can put the screen recording of the spectrum analyzer I have. You can get apps to do this on your phone fairly easily. The one I'm using is called Spectroid, I think. So I will put the screen capture of that down here. I will short the probes out and we'll see what tone this produces. It should be fairly obvious. So if I start this, I'll short the probes out and we can have a look and see. So, if we have a look on the screen, you can see that there are a few peaks, big peaks. There is that peak, it is highlighting at 46 Hz. That is the fairly faint, this one here I'm highlighting with the thing. That peak is the noise that you're getting from the mains. Tom Scott has a very interesting video about this, actually. I'll put a link to that in the description, where he shows how you can use the mains hum recorded videos in order to timestamp them. Very interesting, and a lot of science and maths and stuff that I do not understand. Anyway, we can see over here that we're interested in is these big lines here, these big peaks are the sound that we're interested in. The reason there are so many of them is because of a thing called harmonics, where you have, in radio you get it as well, where you have the thing you've transmitted, and then on either side of it you'll get harmonics, which are very complicated. I am not going to explain them. To be honest, I don't even understand them myself very well. But that's what we're seeing, is harmonics. The main harmonics in this one are at 1000 Hz, 2100, 2000-ish Hz, and 3000-ish Hz. And then there are lots of small peaks up here, 4000 Hz, 5000 Hz, 6000 Hz, so on, right up to 20,000 Hz, which is way, way beyond what humans can hear. Interestingly, if I take pure tones of 1000 Hz, 2000 Hz, 3000 Hz, which are the three main peaks on that, and I play them in combination, it should sound similar to this. Actually, let's try that. I'll do that in post. I'll get those pure tones, and I'll play them now. And I will short these out, and you can compare them. So, again, I'll play the pure tone, and now this. I'll be interested to see how similar those are. In theory, it should be the same. In practice, it might not be because of constructive interference and destructive interference and stuff, which can cause the sounds to be weird, mixy messes. But, we'll see. This will be interesting for me. Anyway, this is a very interesting piece of kit, very useful. I really like the form factor. Actually, this belt loop thing on the back is very nice because you can clip it onto your belt, hold it with you, it doesn't get in the way, and you have both hands free for the probes when you're working. Nice form factor, bomb-proof device. This thing would survive basically anything. I really like this. I like all the BT kit, post office kit, telecoms kit. I use a lot of it. You might have seen some in my other videos. I can't remember what videos I've published and what ones I didn't. But in some of them I've used, like even here on my bench, my go-to analog multimeter is this one. Has telecom on it. And, oops, my conformal coating, aka nail varnish from Poundland, has fallen over. But anyway, you can see BT, British Telecom. This is just my analog multimeter, but it's the one I go to. I use the most because I like it the most. The plugs are a bit destroyed on this particular example, but it still works perfectly fine. I can't remember if I ever used it in a video or not, though. Anyway. More stuff's falling over. Thank you very much for watching, and I will see you in the next one. Hopefully this is fairly short. Probably not, knowing me, I like to ramble, but remember, yes, like, subscribe. I'll see you in the next one. I'm going to shut up now.